Alright, this LeetCode question is called path sum. It says given a binary tree and a sum, determine if the tree has a root to leaf path such that adding up all the values along the path equals the given sum. Note, a leaf is a node with no children. So with the example they give, they're saying the target is 22, and we're returning true because 5 plus 4 plus 11 plus 2 equals 22. Alright, so we're going to solve this problem using recursion. But before we get started, I just want to point out that each one of these red dashes just signifies a null value. I just didn't want to write null a bunch of times because it would make the diagram too messy. Alright, so the key to solving this problem is to realize that the sum has to be correct when we get to this level of the binary tree. Meaning, the node has to have no children, but conversely, we can't have the correct sum at an earlier point either. So let's say the sum was 20. If we started here, we said, all right, this is 5. 5 plus 15 is 20. We might want to say that's true, but it's not because we have to get all the way down to this node. So if we wanted to go down this path, the total would actually be 5 plus 15 plus 3, which would not be the right answer. By the way, this binary tree does have a valid path, and it's right here. We have the number 5 plus 7, which is 12, plus 8, which is 20. All right, so let's go through this once, and let's pretend that our target value is the number 20. What we can do is take the value of every node that we visit and subtract it from the total. If we get to the final node of any tree and it equals the total remaining, then we know that that is a valid path and we'd return true. Let me show you what I mean. All right, so we have the number 20 as our target. Let's start with this. What's 20 minus 5? 15. What's 20 minus 15? That's 0. But remember, that's not a valid path yet because we still have more nodes below it. So at this point, our total that we need is 0. So if any one of these two is 0, that would be a valid path. But instead, if we use the number 3, we have negative 3. And if we use the number 10, we're at negative 10. And remember that we know which nodes to stop on because their children are null. All right, so those paths didn't work. Let's try the other side. Again, we start off with our target being 20 and our first node being 5. What's 20 minus 5? That's 15. All right, so we go to the next node. What's 15 minus 7? That's 8. And we only have one level left to visit. If either one of these is 8, then we have a valid path. We go to the next node knowing that we need a number 8. And here we go, we do have a number 8, so we do have a valid path. All right, so what LeetCode has given us is a function called hasPathSum, which accepts a root and the sum. The root is not necessarily the root like we'd expect, which would just be the number 5. It just means whatever node we're on. So if we're on the node 11, that would be considered the root. And the sum is just our target value. All right, so remember how I mentioned before that if we ever get to a node that is null, then we just return false? That's how we'll start off. We'll say if root equals null, we'll just return false. So if we get to like here or here, those are definitely not valid paths because if we've gotten all the way down there, it means we've already passed the last nodes that have a value, and those values have not added up to the sum. All right. So our next if statement says if the sum is equal to the value of the root we're on, or in other words, the node we're on. And remember that node has to be a node that has no children. So and root.left is null, and root.right is null. Then we can return true. I just noticed I added an extra L up here. Let me get rid of that. Okay, so as I mentioned before, let's say we got to our total on a node that wasn't the last node. That would not be valid. The node would have to be a final node, so a node with no children. And I just noticed that I forgot to add the lines for 7 and 2. Let me do that. Remember, these lines just mean that it has a null value. All right, so the first two if statements basically saying two different ways that we have to be at a final child node. And if we're not, we're going to have to keep recursing. So that would look like this. You would return has path sum root.left sum minus root.val. So all we're doing here is saying we haven't gotten to a final child node, so just pass in the left side instead. Also, subtract the value I'm on from the sum. So this is the example that was given in the description. So sum is supposed to be 22. We started out with 5. So when we say sum minus root.val, we're saying take the sum, which is 22, and subtract 5 from it, which would give us 17. And now what we're passing down recursively is the binary tree starting with this. That's what we mean by root.left. All right, but we can't only do that for the left side of our binary tree. We also have to do that to the right side. So we add has path sum root.right, and then the same calculation, sum minus root.val. Right, so we're at line 14. Does the node we're on equal null? No, it doesn't. It equals 4. Line 18. Does the value of the node we're on equal the total remaining that we need? No, it doesn't. So we'll subtract it from it. So what's 17 minus 4? That's 13. And we pass in the left side of our binary tree. All right, so we're back to line 14. Is the node we're on null? No, it's not. Does the value of the node we're on equal the total remaining we have? So does 13 equal 11? No, it doesn't. So we subtract 11 from our total remaining. That would give us 2. And we pass in the left side again, which would be the number 7. So now we're back to line 14. Does the node we're on equal null? No, it doesn't. Line 18, does the value of the node we're on equal the total remaining? So does 7 equal 2? No, it doesn't. So we'll subtract 7 from 2. That'll give us negative 5. And then what's going to be passed in is its left side. Notice that our left side is null. So now when we go back to line 14, it asks if the node we're on is null. Yes, it does. So this returns false. This is not a valid path. So what it does now is it goes to the second half of line 22, the half where we pass in our right node instead. So what's going to happen is that we almost go back in time. We're back up to here. This negative 5 gets erased. And now we pass in our right side. The right side of 11 is the number 2. So the second half of line 22 asks, does the value of the node we're on equal the total remaining? Yes, it does. But also, does this node have no children? It does not have children. So we've satisfied both cases, so we'll return true. We do have a valid path that totals 22. All right, so let's run the code. Looks good. Let's submit. All right, so our code was faster than about 71% of other JavaScript submissions. As usual, the code and written explanation are linked down below. If you like the video, give it a like and subscribe to the channel. It helps out a lot. See you next time.